Oh, that's irritating. I'm sorry. My kid came in and I accidentally pressed stop instead of pause. Okay, so now I have another part to the video. Oh, it's very frustrating. All right. First times the derivative of the second plus the second times the derivative of the first. Okay, so this is a product rule, not a chain rule. So f prime of x is, here's the first thing, times the derivative of the second thing. So the derivative of natural log of x is 1 over x, plus the second times the derivative of the first. The derivative of 1x is 1. So f prime of x equals, that cleans up to be x over x, which is 1, plus the natural log of x. All right, this looks kind of weird, but this is all in an exponent position. So this is e to the u, and the derivative of e to the u is e to the u du, or u prime. E to the u times u prime. All right, so we want to find the derivative. This is a chain rule. So e to the u is e to the negative 3 over t. And then we're going to, I should have rewritten this first. The derivative, I'm just going to do it this way, d dt of negative 3t to the negative 1. I needed to rewrite that, and I should have rewritten it first. So this is the derivative in terms of t of this negative 3 and t to the negative 1. So I've rewritten it with exponents, so that helps me out a little bit. All right, so this derivative, the power drops down, chain rule. The power drops down here. Negative 3 times negative 1 is 3. And then we decrease the power, t to the negative 2. Okay. And I think this is a great answer. I don't know that I would do anything to clean it up, except to realize that, if you're thinking about this in a denominator, here we have t in a denominator. Well, so t cannot equal 0. It's undefined when t is 0. So that's definitely something to think about. We can't take a derivative when t is 0. Here's the last one here. I'm going to do a little bit of rewrite. That's a v. Because again, no radicals. We want power. So this is v to the 1/2 power. So, this is exponential other base. Other base exponential. And we've got this sort of u. So this is 3 to the u. And if we want to find the derivative of that, this would be dv, but whatever. Then it was, we just did this, the base, same thing again, times the natural log of the base times the derivative of the baby. All right, I think. So I'm going to double check because I think that's what it was. Let's see. So a to the u times the natural log of the base times the derivative of the baby. Very good. Okay. So we're going to go ahead and do that. V, f prime of, in terms of v, is e to the u. So 3 to the v to the 1/2 times the natural log of the base. So the natural log of 3 times the derivative of the baby function here. And the derivative of the baby is 1/2 v. We have to subtract 2 over 2. So it becomes to the negative 1/2. Okay. If you wanted me to rewrite that a little bit, I guess, I'd think this is 3 to the square root of v times the natural log of 3 over, the 2 is in a denominator. This is in a denominator, so the square root of v. Pretty interesting here in terms of domain. The square root, usually, that square root function has to be greater than or equal to 0. But it's in a denominator, which means it can't equal 0. So here, these v values have to be, square both sides, greater than 0. V must be greater than 0. So for instance, we could take the derivative at 2 or 4 or 12 or negative, or sorry, 4.3 or whatever, but we couldn't take the derivative for v values 0 or negative values. Okay, important to think about. All right, ladies and gentlemen, I'm sorry that was 3 videos. It was supposed to be 2. Kids, man, what are you going to do? All right, folks, have a good day.